If total internal reflection should bounce light back perfectly, how can any light show up on the far side of a nanometer scale air gap? In the energy filament theory, total internal reflection creates a boundary-hugging near-field handshake zone that can couple into a nearby surface. Textbooks call this frustrated total internal reflection. Then they flash an exponential decay and hope you stop asking questions. In this view, the math is fine. What's missing is the physical picture of where the energy is actually sitting when the beam can't transmit. When light in glass hits the glass-air boundary at a steep enough angle, the energy C can't organize a clean far-field wave packet into the lower medium, so the disturbance doesn't irradiate away. It piles up as a tight ripple pattern pinned to the boundary, strongest right at the surface and fading fast as you step away from it. That fading is the whole clue. This is not a traveler leaving home. It's a local tug-of-war that only exists within arm's reach of the interface. Now brings a second prism close enough that its own boundary enters that reach. You didn't violate reflection. You gave the trapped boundary ripple a new place to lock onto, so energy can hand off across the gap and re-emerge as a normal propagating wave on the other side. It sounds abstract. Think of it like this: press your ear to a wall and suddenly you hear through it. Not because sound teleported, but because you coupled to vibrations that live right inside the wall. Or picture two people separated by a thin curtain. From across the room nothing transfers, but up close a firm handshake through the fabric becomes possible. The gap distance matters for the same reason. Make the gap wider than the handshake zone, and the boundary ripple fades before it can grab the second surface. Make it smaller, and coupling becomes strong enough that the energy is picked up and carried onward. Notice what didn't happen. No free-running wave packets crossed the forbidden region. No messages jumped ahead of local causality, and nothing went superluminal. Everything is local coupling at boundaries, with the energy C responding where it is actually touched. The punchline is simple. Frustrated total internal reflection isn't a ghost wave crossing nothingness. It's a near-field shortcut that appears when two boundaries are brought within reach. Next episode, we'll make the bigger split crystal clear. Near field and far field aren't strong and weak. They are two different ways energy is organized. Tap follow, share it on New Physics, Clear Universe.